Hi everyone. The fundamental counting principle examples that I assigned on Monday, the 10 questions or the 10 examples that you worked on, there are usually a few of them that people struggle with. The ones that people struggle with or usually ask me are number 3, number 4, number 6, number 7, number 8. No, I'm sorry, not number 8. Number 9, and obviously number 10. Number 10 is the hardest one. So these are the ones that I'm going to take up. And if there's any others that you need, you can definitely contact me. So if we start with number 3, it says a deck contains 52 cards, which we already know from the lesson. How many ways can 2 cards be drawn in succession? And the key word in that example is the word succession. Succession means one after the other. So if I'm looking at making 2 draws, okay, and I want you to envision me fanning out a deck of cards in front of you. So on your first draw, you have 52 choices. You take that card, you put it in your pocket. I fan the cards out in front of you again. And now on your second draw, you have 51 choices. So how many choices do I have on the first pull? How many choices do I have on the second pull? For a total of 26, 52. Now, where there ends up being a little bit of confusion in question 4 is that it's the same question. A deck of cards contains 52 cards. How many ways can 2 face cards be drawn? So when we talk about face cards, we're talking about kings, queens, and jacks only. So there are 4 kings: King of Hearts, King of Clubs, King of Spades, King of Diamonds. 4 queens: Hearts, Diamonds, Spades, Clubs, and 4 jacks: Hearts, Diamonds, Clubs, and Spades. So in total, if I was to fan out the face cards in front of you, there would be 12. You pick one of them, you put it in your pocket. I fan out the cards that are remaining. There are 11. 132 possible ways. So face cards are always starting with 12 items. Okay, let's take a look at 6. How many ways can a student answer a true and false test if there are 6 questions? I want you to envision it. 6 questions. True or false? So how many choices for question 1? 2. How many choices for question 2? 2. Question 3? 2. Question 4? 2 choices, true or false. Question 5? 2, true or false. Question 6? 2, true or false. 2 times 2 times 2 times 2 times 2 times 2. 64 possible ways. Question 7. This one's a bit tough, to be truthful. The final score of a soccer game is 6-3. Okay. How many different scores were possible at halftime? So at halftime, we could call it the first team. Your first team, we could have had 0. So it could have been 0 at halftime for the first team. It could have been 1. It could have been 2, 3, 4, 5, or they could have scored all 6 points in the first half. So the first team actually has 7 possible choices for their score. 1, 2, 3, 4, 5, 6, 7. The second team, we'll call it, could have been 0 at halftime and scored everything in the second half. Could have been 1, 2, or they could have scored everything possibly in the first half of the game. So the second team, Team B, they've got 4 choices. 7 choices for Team A, 7 choices for Team B. Question 9. When a 3-digit area code were first introduced in 1947, the first digit of the area code could have been anywhere between 2 and 9. So 2, 3, 4, 5, 6, 7, 8, 9. The second digit of the area code had to be a 0 or a 1. And the third digit of the area code, I guess it doesn't say anything, could be any value. So 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. It says, how many area codes were possible under this system? Well, the first digit, how many choices did I have? 1, 2, 3, 4, 5, 6, 7, 8. The second digit, how many choices did I have? 2. And the third digit, how many choices did I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 8 times 2 times 10, 160. So because they said nothing about that third digit, then the assumption is it could be anything. There were no stipulations whatsoever put on the third digit. Okay, let's go to question 10. Question 10 really would have been the only application question given in this particular set of homework. So let's take a look at it. 10 finalists are running in a race at the Canada Games. How many ways could a gold, silver, and bronze medal be awarded? Okay, I want to describe this as an analogy to you. I go to these Canada Games, and for whatever reason, I get the honor of handing out the gold and the silver and the medal bronze, or the gold, the silver, and the bronze medal. So I'm standing at the finish line. I'm on a podium with the 3 medals, and the runners come around the corner, and they're all heading towards me. So I'm watching them come, and I've got the 3 medals in my hand ready to give them out to the winners. So as I'm watching the runners come towards me, how many people are running towards me? 10. That winner crosses the finish line. I give him or her the gold medal. How many runners are now coming at me that have the possibility of winning silver? 9. That person crosses the finish line. I give them their silver medal. And how many more are running towards me that are available to win that bronze medal? 8. 10 choices for gold, 9 choices for silver, because somebody already has the gold in their possession, and 8 choices for bronze, because 2 individuals already have the gold, the silver, and the third person is winning the bronze. Part B. One of the finalists is a friend from Welland. How many possible finishes would include your friend winning a medal? And the key words there are winning a medal. So what is happening in this part B is you've got 3 scenarios. Friend wins gold, or friend wins silver, or friend wins bronze. So with your friend winning a medal, your particular friend could win a gold, or your friend could win a bronze or silver, or your friend could win a bronze. We all know from our initial note that or means add. Okay, so now let's think of each of these scenarios. There are 3 medals. Again, I'm standing at the finish line with the 3 medals in my hand, waiting for the runners to come. They come around the corner. Oh my goodness, my friend is in the lead. Oh my goodness, my friend's actually going to win the gold. That's your friend. The one person you know who's winning the gold, your friend. So that means then, how many other runners are still out there that could possibly get the silver? And how many other runners are out there that could possibly get the bronze? There you go. There's my friend winning gold. Let's think about this scenario. Again, I'm waiting at the finish line and I see the runners come around the corner and I see my friend. He is in second place. It looks like he's going to win the silver. It very much looks like he's going to win the silver. That means how many other people have the possibility of winning the gold? How many other people have the possibility of winning the bronze? Okay, third scenario. Yep, there I am again at the finish line, and I have the 3 medals in my hand. They come around the corner. I see my friend. He's steadily, going to be that bronze person. How many other people are available for the gold? How many other people are available for the silver? And my friend wins bronze. So here's my friend winning gold. Here's my friend winning silver. Here's my friend winning bronze. 72 ways for my friend to win gold. 72 ways for my friend to win silver. 72 ways for my friend to win bronze. For a total of 216 possible ways for my friend to win some sort of medal. Okay, let's look at C. How many possible finishes would leave your friend out of the medal standings? Okay, let me think about this. Again, I'm standing at the finish line and I've got the 3 medals in my hand and the runners come around the corner. And I see my friend. He's doing pretty darn good. But guess what? All of a sudden he falls, and falls to the extent that he's not getting up, that the stretcher is coming out and the ambulance is there and they're taking him away to the hospital. So my friend is completely out of the race now, completely out of the race. So if he's gone to the hospital and completely out of the race, how many choices do I have for gold? 9, because there were 10 runners, but one's gone to the hospital. How many choices do I have for silver? 8. One person's gone to the hospital. One person's already won the gold. How many choices do I have for bronze? 7. One's at the hospital. One's won gold. One's won silver, for a total of 504 possible ways. So hopefully this helps, guys. And this will help you do your second set of problems. Okay? If there's anything else you need, don't hesitate. Talk soon.